Okay, continuing practice problems in section 12.6, other coordinate systems. Here we're doing number 10, and it wants us to convert this cylinder into spherical coordinates. The cylinder is x squared plus y squared equals 9. Don't be fooled, it is not a circle of radius 3. It simply projects into the xy plane as a circle of radius 3 centered at the origin. But because the z value is unrestricted, it extends upward and downward, and that makes it a cylinder. Okay, how to convert it to spherical coordinates? Well, let's take a look at the conversions. The x coordinate in spherical coordinates is rho sine phi cosine theta, and the y coordinate is rho sine phi sine theta. So it just means squaring these, adding them together, and setting it equal to 9. So it will be rho squared sine squared phi cosine squared theta plus rho squared sine squared phi sine squared theta equals 9. And I think you can see we've got a common factor of rho squared sine squared phi. And once that's factored out, we'll have sine squared plus cosine squared theta. So the theta term will simply drop out as a 1. So it becomes rho squared sine squared phi equals 9. And we can even take the square root here and make it rho sine phi equals 3. You might worry about the plus or minus 3 that is due to the square root of 9. But let me show you how we can kind of eliminate that, okay? Let's take a look at this cylinder and see how this formula really generates it. So again, in three-dimensional space, we have a circle projected into the xy plane, and then of course, that extends upward and downward really forever. So this is an infinitely large cylinder. Well, let's take a look at this function right here. It's basically saying that the hypotenuse that runs all the way out to the surface of the cylinder from the origin. Remember, this angle right here is phi. And if we look at it, that far side, the horizontal projection of that far side is going to represent the actual radius of the cylinder. This has to be 3. And you notice in terms of right triangle trigonometry, we're pretty much guaranteed with this being a right angle, this being phi, and this being rho, that the sine of phi is equal to the opposite side over the hypotenuse, and that's r over rho, or r equals rho sine phi. Basically, whenever phi changes up or down, it'll simply change the length of the radius to guarantee we always remain on the surface of the cylinder. When phi is 90 degrees, it's all the way down at the bottom, sine phi will be 1, and rho will represent the radius. As phi gets smaller and smaller, of course, rho has to grow larger and larger to ensure that it still hits the surface. Notice with no restriction on theta, this can swing around in 360 degrees, and as long as rho remains above, then, or as long as phi remains above the xy plane, then we'll end up with all the positive values. And if we go down below, we'll end up with the negative value. So that's why we don't really need the plus or minus. As long as phi remains the angle between the rho direction and the z-axis, that can be either above the xy plane or it can be below the xy plane. And in both cases, these are basically measured in the same way. So each point is really two different points depending upon where rho is measured. Rho and phi are always measured from the positive z-axis. So as long as we allow the angle to march all the way through, these will be negative values for z, and these will be positive values for z.